Hello guys, how are you today? So today I'll be explaining the chemistry AMS quiz of term 2 week 12. So let's start with the first question. Why are alloys used instead of pure metals? Majority of the time we use alloys because they have more desired properties lacking in pure metal. For sure, if you mix two metals with strong properties, you might get a metal or an alloy with a stronger property. So they have desired features that is lacked in most pure metals. For example, some metals may undergo rust easily, whereas, for example, gold will undergo rust very easily, but when you add copper to the gold, it will not undergo rust. That's why most of the jewelry, especially for the women that we wear, it is not pure gold, but it is like gold and copper. Okay? We move on to question number 2. In question number 2, they said an aluminium alloy is used instead of pure aluminium in aircrafts. Why is aluminium alloy used instead of pure aluminium? Because the aluminium alloy is stronger than pure aluminium, this is for sure. More abundant in nature. Why would we choose something if it's more abundant in nature and it does not benefit us? Even if it is more abundant in nature, that does not mean it will benefit us. More reactive than pure aluminium, okay, this, we are using it in aircrafts. We do not need it to be more reactive. We need it to be less reactive so that it can sustain the aircraft. Aluminium alloy has lower melting points, for sure not. Imagine going up to the plane and then you will see that it has already melted because it's made out of an alloy that has a lower melting point than pure aluminium. For sure not, so definitely the first option is correct. We move on to the question 3. Which of the following are general properties of transition metals? Transition metals are what? They are these metals over here. Before the transition metals, we have two groups. We have the alkali groups and the alkaline groups. They each have their own properties, but for now, the properties of the transition metals, which are over here, you should know that they are denser, they have more than one oxidation state, they have catalytic properties, they have higher melting points, they are good conductors, they are hard and tough, and one more thing is that they create colored compounds. If we took an example, which is Fe, iron, we know that iron has more than one oxidation state. It has Fe3 plus and Fe2 plus. And both of these have different colors. This is reddish brown, this is greenish blue, almost. This is quite literally all you need to know. So it has catalytic properties, they are denser than other metals, and each may have more than one oxidation state. They for sure have higher melting points, they are good conductors, they are hard and tough, and they form colored compounds. We move on to question number 4. They said an alloy is a solution of a metal with other metals or non-metals. Whenever you see solution, you should know two things. Okay? What it does not mean and what it means. Now for alloy, an alloy solution, we will see what it does not mean and what it means. First of all, what it does not mean. It does not mean that it's gonna layer. It does not mean that one metal is gonna layer another metal. It does not mean that all the metal ions are gonna be replaced. So replaced all metal ions or metal atoms. For sure not. Okay? It does not mean that they will repel. However, it does mean that it will replace some atoms. It means replaced some atoms. Okay, and it occupies the empty spaces. So will occupy space or gaps. So occupies empty spaces. So here if we're choosing, we know that it's not gonna repel, it's not gonna layer, it's not gonna replace all host atoms. However, it will occupy these spaces and it will replace some of the host metal atoms. We move on to question number 5. Which of the following are ores from which iron is extracted? How do we extract iron? We extract it using a blast furnace. What do we extract the iron from? We extract it either by manganite or hematite, but in this case we can call them iron ores. So you extract iron from iron ores, meaning it's only made up of iron and oxygen. So iron is extracted from iron ores being only made up of iron and oxygen. What are the raw materials used in a blast furnace? Now, we talked in the previous question that in a blast furnace, what happens? They will take the iron ore and they will make it go through the blast furnace. They will burn coke. So coke is carbon solid, which is a fuel. They will use hot air and they will also use limestone, which is also known as flux. And this iron ore will be transformed into iron liquid. So what are the raw materials used in a blast furnace? You should know it's coke, which is the carbon as a solid. It's air, hot air, and limestone, as well as the iron ore. So the iron ore, the coke, the hot air, and the limestone. We move on to question number 7. Which of the following reactions may normally take place in a blast furnace? We said in a blast furnace, what happens? We will take an iron ore. We will use coke, hot air, and limestone. Alright, and then it will produce what? It will produce iron as a liquid. What you need to know is that there are 3 main processes that happen in the blast furnace. The first process, it is the combustion of coke. So coke will combust, that means it is carbon as a solid, and you add to it oxygen gas and it will produce for us carbon dioxide gas. Okay, this is the first thing that will happen. The second thing that will happen is the reduction of ore. That means the iron is gonna gain electrons. Or in another term, it's very simply that the iron ore is gonna undergo a reaction with carbon monoxide, okay, to produce for us liquid iron and carbon dioxide. So here it is the ore, the iron ore, in addition to carbon dioxide gas, that will form liquid iron and not carbon dioxide here, it's carbon monoxide. So it's an ore plus carbon monoxide will give us liquid iron plus carbon dioxide gas. And then finally, the last step, it is the formation of slag, so slag formation. And very simply, the equation is CaO, okay, calcium oxide plus SiO2, silicon dioxide. This will give us calcium silicon trioxide. So keep in mind, the 3 main processes that happen in the blast furnace, they are, first of all, combustion of coke. Okay, the equation is carbon solid plus oxygen gas will give us carbon dioxide gas. Then reduction of the ore. It's the iron ore plus carbon monoxide gas will give us iron liquid plus carbon dioxide gas. Slag formation. It is calcium oxide plus SiO2 will form CaSiO3. So in this case, you will choose them all. We move on to question number 8. Which of the following conditions favor rusting? To favor rusting, you need to be in the presence of air. You need to be having a reactive element, more specifically a reactive metal. You have to have salt and a very high temperature. So presence of an inert element, for sure not. Presence of salt, yes. High temperature, yes. And absence of air, for sure not. You should have the presence of air, not the absence of air. Which of the following are uses of copper? You use copper to make electric cables, to make alloys, to make ornamental works, but for sure you don't use it to make carbon dioxide. We move on to question number 10. What flame will calcium salts give? Just memorize calcium, Ca2+, then you have Li+, Na+, K+. This gives brick red. This gives orange. This gives red. This will give us red. The Na+ will give us orange, yellow, kind of. And finally, the K+ will give us lilac. So, calcium salts will give us brick red. Okay? Okay, now we move on to question number 11. Number 11, hydrocarbons are organic compounds. Which of the following atoms are the only ones present in hydrocarbons. Hydrocarbons, from its name, that means it's made out of carbon and hydrogen, very simply. We move on to question number 12. Here, these you should have memorized them from now. So alkanes, their general formula is CnH2n plus 2. And the molecular formula of an alkane having 2 carbons, just substitute, it becomes C2H. 2 times 2 plus 2. So you will get C2, put capital C, C2H6. Okay, we move on to question number 13. They said, which of the following is the general molecular formula for alkenes? You should have also memorized them. It is CnH2n. So the molecular formula of an alkene having 2 carbons, it's going to be C2H4. We move on to question number 14. They said, pure iron is extracted from hematite in a blast furnace. Which of the following are mixed with hematite before being introduced from the top of the furnace? Select all that apply. Okay. Which are mixed with hematite before being introduced from the top of the furnace? You should know that at the beginning of the blast furnace operation, it will be the iron ore. It will mix with coke, which is the carbon as a solid, and it will mix with limestone, okay, as well as with hot air. But since hot air is not an option, we're not going to choose it. You choose only coke and limestone. Then they told us in part B, choose the substance that is introduced from the bottom of the furnace. So from the bottom of the furnace, what's going to be introduced is hot air. Keep this in mind. Now, a series of reactions occurs in the blast furnace. Give the chemical equation for the formation of carbon dioxide from burning coke. Burning coke, that means it is carbon as a solid form. Okay, so it is carbon as a solid form in addition to oxygen, because we said whenever we have coke as a solid, we are gonna have combustion. So combustion is always with oxygen, and it will produce what? It will produce carbon dioxide. CO2. Now, don't forget to put the states for the O2. The O2 over here, it is gas. And the CO2 over here, it is also gas. So keep in mind, when they say carbon dioxide from burning coke means it is carbon as a solid. Okay, then you add to it oxygen as a gas, you combust it, and then it will form carbon dioxide gas. Okay? Then we move on to the second process. They said give the chemical equation for the reduction of carbon dioxide after reacting with excess coke. So look, carbon dioxide, it is CO2, and we know CO2 is a gas. It will react with excess coke, which is the excess carbon solid. And what will it produce? It will produce carbon monoxide. And carbon monoxide, it is a gas. Do not forget to balance it. So after balancing it, it will be like this. So carbon dioxide plus coke as a solid is going to give us 2 carbon monoxide gas. Now give the chemical equation for the reaction of hematite, which is Fe2O3 with carbon monoxide. So look, very simply, Fe2O3 in addition to carbon monoxide gas. So Fe2O3, it is a solid for sure. Carbon monoxide is a gas, okay? It is going to produce what? It's going to produce iron as a liquid. So for the liquid, we will put L. So iron as a liquid in addition to what? In addition to carbon dioxide gas. Okay? And now, of course, we have to balance it. So when you balance it, you are going to get that you have to put a 3 over here, a 2 over here, and a 3 over here. So keep in mind, the iron ore plus carbon monoxide will form iron liquid plus carbon dioxide. Now, for the last part, they said calcium oxide, CaO, produced from the decomposition of calcium carbonate reacts with silica impurity, SiO2, to form molten slag. Give the chemical equation for the formation of slag. Slag, it is formed by what? Calcium carbonate, calcium oxide. They told us calcium oxide over here, CaO, it is what? It is a solid, okay? It is gonna react with SiO2, which is also a solid, okay? And it's gonna form what? It is gonna form slag. And you should memorize that the equation of slag, it is calcium silicon trioxide, okay? And of course, don't forget to put that it is a liquid, because slag is a liquid. Okay, so now for part D, the iron obtained from the furnace is called cast or pig iron. Now choose the major impurity in cast or pig iron. It is definitely for sure carbon. So keep in mind that the biggest impurity is carbon. We move on to question number 15. The metal to be protected is connected to a more reactive metal. Okay, keywords. Here the most important thing is keywords. When you see metal to be protected is connected to more reactive metal, this is called sacrificial protection. Whenever you see that the metal to be protected is coated, how do we do coating? We use something called electroplating. The metal to be protected is coated with zinc. Whenever you see zinc, our key word is zinc, so we are going to put galvanizing. So, more reactive metal, sacrificial protection, coated electroplating, zinc is galvanizing. Question number 16, again this talks about transition metals. We know they form colored compounds, they have catalytic properties, and they have more than one oxidation state. We move on to question number 17. An unknown metal X is soft and has a low density. So if the metal is soft and it has a low density, then for sure it's probably an alkali metal. For sure. Alkali metal, these are these metals over here, which are excluding hydrogen for sure. It is lithium, sodium, potassium, rubidium, cesium, and francium. Okay, these are the alkali metals. We move on to question number 18. Write the chemical equation for each of the following metals with oxygen gas. Do not include state symbols in your equation. Use the smallest whole numbers to balance the equation. Okay. First of all, they said they want what? They want the reaction with the following metals with oxygen gas. So potassium, K, okay, it's gonna react with oxygen gas, O2, to produce what? How do we know what its product is gonna be? For sure, it's gonna be an alkali oxide, because we know alkali metal plus oxygen will form alkali oxide. However, how do we know what it is going to form? We have to take their ions. The ion of K, it's K plus, and oxygen, it is O2 minus. Then we do the crisscross method, and we are going to get K2O. So an alkali oxide is K2O, but is it balanced? For sure, it's not balanced. So to balance it, we will put a 2 over here and a 4 over here. So now the final product, okay, is 4K plus O2, pay attention, they do not need state symbols, so you do not put the state symbols, will give us 2K2O. Okay, we move on to part B, magnesium. You should know that magnesium plus oxygen, it will form something. Magnesium is an alkaline metal, so alkaline plus oxygen will form an alkaline oxide. Okay, now let's do the crisscross method. Alkaline, they are over here. So that means they have a charge of 2 plus, or an ion, an oxidation number of 2 plus. So it's Mg2 plus O2 minus. You do the crisscross method, you're gonna get MgO. So very simply, it means that Mg plus O2 will form MgO. As you can see, it is not balanced, so you're going to put a 2 over here and a 2 over here. And just like that, it's going to be 2Mg plus O2 will form 2MgO. We go to the last one, which is iron. Iron, Fe forms Fe3 plus ion. So keep this in mind, it's Fe3 plus. They told us that iron, Fe, will react with oxygen to form what? Iron, it is what? A transition metal. It will react with oxygen to form what? To form an ore or an iron oxide or you know. So very simply, they said the ion is Fe3 plus Fe3 plus O2 minus. We will do the crisscross method. We will get Fe2O3. So now it is Fe2O3. Is it balanced? For sure it's not balanced. So to balance it, we're going to put 2 over here, 3 over here, and 4 over here. So very simply, it becomes 4Fe plus 3O2. It is gonna form 2Fe3, not Fe3, sorry, Fe2O3. So 4Fe plus 3O2 is gonna give us 2Fe2O3. We move on to question number 19. Here, very simply, look, it is what? It is an alkali oxide. So alkali oxide, if you add to it water, it is always gonna form for us an alkali hydroxide. Always keep this in mind. So our product is gonna be an alkali hydroxide. What does alkali hydroxide mean? Very simply, it is the metal alkali plus the hydroxide, which is always OH. So our metal in this case, it is Na. Na plus OH, put it together, you will get NaOH. So now, Na2O solid plus H2O liquid is gonna form for us what? NaOH aqueous. Okay? But it is not balanced. So very simply, to balance it, you're gonna put the 2 over here. So you're just gonna add 2 NaOH and then you're gonna put aqueous. So that is it for question number 19. We move on to question number 20. In question number 20, we have an alkaline metal plus oxygen. So it's gonna form an alkaline oxide. Okay, so here we are gonna use the ions. Okay, so it's gonna be Ca2 plus O2 minus. You do the crisscross method, you will get CaO. So the product is gonna be CaO. Of course, it's not balanced, so you're gonna put 2. And CaO is a solid. So very simply, it is 2CaO solid. We move on to question number 21. Choose the correct answer. The above picture represents the model of an alloy. How do we know it's an alloy? Because first of all, it's metal. It has metals in it. Okay, these are the metals. And then it has non-metals. And then it has small sizes, medium sizes, big sizes. So for sure, it's a solution which is made of metal and non-metal. So it's an alloy. We move on to question number 22. In question number 22, drag and drop the material used in each of the components for copper refining to make copper refined. Or in other terms, we are electroplating the copper, or we are coating the copper. What we need to do, first of all, the thing that we are gonna plate the metal with, we will place it in the anode. The metal that we are gonna plate, we will place it at the cathode. And of course, the solution has to be either acidified or molten or aqueous. Okay, and the solution is the electrolyte. So we are gonna be plating the metal. We are gonna be plating it is pure copper. We're gonna plate it with impure copper, and the solution or the electrolyte is gonna be acidified copper sulfate. We move on to question number 23. We need to know the flame test for each. You should know that lithium is red, potassium, it is lilac, and sodium ions, it is yellow-orange. I know I said orange before, but now in cases like this in the exam, they would prefer if you put yellow and not orange. So that would mean that calcium is brick red, lithium is red, potassium is lilac, and sodium is yellow. We move on to question number 24. Ethene, C2H4, has the following structural formula. Ethene reacts with hydrogen gas, H2, at high temperature and pressure. Choose the type of reaction that happens. Because ethene is an alkene, it will undergo addition. Okay? Now, after it undergoes addition, that means you add H2 to the thing. you add H2 to the alkene, which is C2H4. It will become C2H6. So it's C2H4 plus H2, so C2H6. Now, C2H6, it has the formula of CnH2n plus 2. And this is an alkane. So it has the homologous series of product of hydrogenation being an alkane. And alkanes, they are usually saturated, meaning they only have single bonds. Choose the reagent that converts ethene into ethanol. We know that it is steam, very hot water. So water as a gas will convert ethene into ethanol. And now finally they said ethene reacts readily with chlorine Cl2 at room temperature. Locate the product of a reaction between ethene and chlorine. We know ethene undergoes addition. So if this is ethene, and it undergoes addition, so it will break the double bond. It becomes C single bond C, H, 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 bond here. And because we're adding Cl2, so a Cl goes here and another Cl goes here. So this is the answer we are looking for. Now, finally, select the structures of unsaturated hydrocarbons. So, unsaturated hydrocarbons, they are what? They are hydrocarbons that are not alkenes, meaning they do not have only single bonds, they have single bonds, double bonds, triple bonds, etc. Whatever they have, okay, it's like gonna be something with bonds and not only single bonds. So you cannot choose this because it has only single bonds. You can choose this, you cannot choose this, it has only single bonds, and you can choose this. So let us submit. I hope there were no mistakes. I think there might have been a mistake with one of the typing, so let us see. Yes, there is a mistake with the typing question. This one over here. I noticed this mistake. I don't know. I found it really funny. So look here in the online quiz result. This is which question? Question 14. So look at this question over here. The person who made the exam put 1, but here it's supposed to be liquid. So I found it really funny. So please, in the exam, put it liquid and not 1. Put it as liquid. Here it's a mistake from whoever did this exam. Okay, so let's submit. Ignore this, okay? And thank God, because they were all correct except this one mistake, which is not a mistake. It's a mistake from them. So thank you guys for watching. I hope you enjoyed and have a wonderful day.